Okay, so today we are going to look at MSE or mean squared error, and it can be used as both performance metric and a loss function, or in other words, as a way to easily understand how good or bad your model performs, and also as actual part of training phase. So mean squared error is a function, and if the notation doesn't make any sense, I hope it will get clear as we go along. This function is designed for basically measuring the overall performance of a model. So it takes two lists of values, true values and predicted values. And there are three words in the title of this function, and these mean three different operations. The error means we have to subtract one list from another, so we iterate through all values of both lists and subtract corresponding values. Next, there is a word squared, so we simply square each of our resulting values. And the last word is mean, so we add them up and divide by the number of values in any list. I say any because, of course, we have to have the same number of values in both predictions and true values. And just like that, we have our MSE value. But what does it mean? So we have to understand a few things. The first one is that the lower it is, the better our model is. So the perfect value is of course 0, but it can go up to plus infinity. The next very important thing is that it uses square, so it makes larger errors have a lot more impact than smaller ones. An error of 2 will have 4 times larger weight than an error of 1. And this is because we square those differences. And lastly, MSE is in squared units. So for example, if you're predicting house prices in dollars, MSE is in square dollars. So sometimes for easier interpretation, you can use square root together, making it RMSE or root mean squared error. Let's jump to Jupyter Notebook. I will use Google Colab, and let's write two implementations of mean squared error. The first one is slower but easier to understand, and the second one will be much faster. So let's define two Python lists. The first one is yTrue, and it will hold true values. And the second one is yPred, and we'll use it for our predictions. For now, we can just fill some random values in both. And the more similar these values are, the lower mean squared error value we are going to see. And now we have to define our function. So we called it mean squared error, and it has to take our two lists. Inside our function, we have a new variable called squared, where we will store all squared differences. So it should be empty at first. Next, we iterate through both lists at the same time and store squared differences to our squared list. And the only thing that's left is finding the average. So we sum up all the values in our squared list and divide them by the length of our list. And this is it. We can check if it works by calling it on our example lists. And I also recommend you to play with those values a little bit to get a bit more intuition about how they influence the final result. Now, with Numpy, this is a lot simpler and a lot faster. Let's create another function, mean squared error Numpy, and it will take the same two lists, but we have to turn them into Numpy arrays first. And now it is a simple one-liner that's left. We don't have to iterate, we can simply subtract one array from another. Square the result, as this is element-wise operation if we deal with Numpy arrays. And we use a mean function that is built into Numpy. And we can see that we get the same result. And that's it. In a few minutes, you have a working implementation of mean squared error and hopefully a clear idea of how and why this function works. That's it from me for today, and I'll see you next time.